have 2 examples. We should get them done. They usually, class normally is 3 parts, so just the way of it. All right. I'll let you fly a little on your own on this next one, since you've seen one. See what you can do with this one. Example, next example, the summation as n equals 1 of 1, the summation n equals 1 to infinity of 1 over the square root of n. So, first of all, you have to be the police, the detectives, and the cops. And you have to run to the scene of the crime and tell me, is it meet the requirement? Decreasing, positive, and continuous.
Square root of n.
Alright, we're plugging it in our calculator now. We get 1 nod, I'll go with 2 nods.
So it has to be positive in the...
Positive means it's above the x-axis.
The whole way, or just in
No,
the first
from 1
quadrant?
over.
Oh, okay.
It is.
Alright, so the police, the cops, and the detectives have concurred, so we can use this test. Alright, go ahead and change it to a function, so we take it out of series land into our familiar function land, and the n becomes an x, and we have a dx, and we have an integral, and it's improper, and there's a limit, and so on. But that's where we're comfortable, right?
I want to say comfortable.
More comfortable.
And more comfortable.
Maybe.
Alright, what is the integral of square root of x being in the denominator? That's what, in your thoughts,
X to the 1
x to the
half.
minus 1/2. So when we take the integral of that, it goes x to the 1/2 times 2, is that right?
Here.
Alright, the limit as b approaches infinity of x to the 1/2, so that's square root of x with a 2 in front of it, from 1 to b. So, we need, as I said, we have a collection of graphs over here. The square root function starts abruptly at the origin and just keeps on rising. So Gianni, what happens to this when we put in infinity?
It goes to infinity.
And so therefore it diverges, and therefore, my little mathematical symbol, therefore this series n equals 1 to infinity of 1 over the square root of n also diverges. Not bad, not bad test. I think you can do these well. Try for me 1 over n cubed. 1 over n cubed. So we're now doing the summation as n goes to infinity of 1 over n raised to the 3. Well, I'm actually going to erase the theory, so I have some room here. And you go ahead, you're doing 1 over n cubed. Alright, I'm not even going to do it. I'm just going to let the class do it and get me the answer. Remember, it's x to the minus 3 that you end up doing your integral of. Oh, duck, go away. Alright, are you getting anywhere with that?
Kind of.
So the integral, I'm not right doing it out, but you will just tell me what the integral is of this. What does it come out to be? Just give me the last step. So I would have the limit as b approaches infinity. Do you have an integral for me, Brendan?
After I integrate it?
Yeah.
Negative
That's why I'm
1
checking
half.
to make sure you integrate it.
Negative 1/2 n to the negative 2.
Alright, so that means, can I write that as a negative 1 over 2 x squared? Is that what you said?
Yes.
Alright, so that's from 1 to b. So we end up taking the limit So Johnny, what happens this time as we go out to infinity? So we get a b squared, but it's in the denominator, and a 1 squared in the denominator.
Shouldn't the second one be negative?
Yeah,
minus
because
one.
it's a negative negative, is that what you mean?
Yeah.
Yeah, you're right. So we subtract it because we're putting in the lower limit, so it's already negative. So what do we end up with? What values?
Infinite, or 0 minus plus 1/2.
0 plus 1/2, which is 1/2. Therefore, the series that I just said, n equals 1 to infinity of 1 over n cubed, converges. Does it converge to 1/2, class?
No.
Okay. Alright, it converges to something, but not that. Alright, I just have a closing comment before I give your assignment. And I'm just going to sort of gather some information and see if you can make an observation that is similar to an observation you made before. So this important observation has no board space left, so I have to fit it in there. When we did this series earlier today, did it converge or diverge?
It diverge.
Alright, that's the big harmonic series. So this is a diverge. Alright, then when we did this one, I've got several here I want to pull together. So did that one converge or diverge?
Diverge.
Diverged. Alright, then we just did 1 over n cubed. Did that converge or diverge?
Converged.
Did we do any others today?
1 over x squared plus 1.
N squared, okay. I gotta make this point. Alright, bar down the door, don't let them in. Alright, so this one,
It was plus 1. N squared plus 1. On the
okay,
board.
I don't want that one. Did we do 1 over n squared?
No, I don't think
I
so.
don't think so.
Alright, well, it did converge as well. We should have. We should have. There's a pattern here. So this is 1 over n to the 1. This is 1 over n to the 1/2. This is 1 over n to the 3rd. And this is 1 over n squared. Yeah.
Can I take a guess?
Yep.
If the exponent is less than 1 or equal to 1, it diverges.
It does, and we've had this before. It came out in section 8.6 where we were doing the same thing with intervals that were converging or not, and we called them p-series. So you may also use that to quickly do some of your homework problems.
So we don't have to write them out if we can use
No,
that?
you can just say p-series, p-series is n to the p. So if p is less than or equal to 1, then it diverges. If p is greater than 1, it converges. So we'll go over that again tomorrow, but you might find it helpful tonight. Alright, the assignment, give you you didn't have any work time. Where does the time go?
Chapel day.
I'll just give you 8 problems to do. So, and I'll make a video of the book for them, so you can shut that down now. And I'm going to give them the assignment and you the assignment on the next part. See you in a bit.